Good day. I am the Draft Doctor, and in this lesson I am laying out a pitch squared round. This pitch squared round has a 30-degree angle on it. It's 12 by 8 at the rectangular end and 7-inch round at the top. Now, I've gone ahead and made my elevation view. I've put my profile on the top. I've divided it into equal spaces and I've numbered them. Now, in order for me to get some lengths that I can triangulate with, what I need to do is project this up into plan view as well. So if I just bring that up like that, and I'm going to bring this corner up like this. This is what we see in the plan view. I know it's not the same length as the 12, but we're not going to worry about that right now. And if this is 8 inches and this is my center line, then I would have to come up 4 inches to that edge. And I'll have this profile and we'll be using it as part of our plan view. So now on my 3/8 scale, I need to go up 4 inches, and that right there is now a half plan view. This would be my seam. This would be my seam. And let's just mark this in here. Well, I've kind of connected my views together. And there's a reason for all this. Here. Now, if I don't look at that, there is a half view of my fitting. Now, in order for me to triangulate these lengths, I have to triangulate over the difference in the falls from center line. Now let's say, take an example of number 4. 4 is falling from center line half of the diameter, and its relationship to A and B is the fall of the difference right here. So in order for me to triangulate that, here's a little trick that I like to use. What I'm going to do is just extend these up to the edge of my base, my 12-inch side that I'm seeing in the plan view here. And in essence, what this is going to accomplish is it is going to give me 7 true-length triangles with the fall already incorporated into them. When it comes to triangulation, we are always looking for true-length triangles that can be utilized. So I'm just going to extend that now, probably into my pattern, but that's okay. And we're ready to start. I've laid out AB. I flip-flopped them from BA so that I would get a nice inside pattern. Here is the length of my A to 4. Now, if I use the fall of 4 and I take this and mark it from 4, I have a true length triangle for that particular fall. And now I'm just going to take the true length of that, and from A, somewhere on this arc, will be 0.4. Where on that arc? Well, we're going to find out that when we triangulate B4. There's our plan length of B4. Now I'm using the fall of 4 to the edge. There's my plan length. My true length is the hypotenuse to this point here on the round. And there we have it. And from B, I find 0.4. Try to make that first arc kind of big because I never know where it's going to intersect with these kind of fittings. So obviously I didn't get it in the right spot. And now I have. There's my 4 point. From the 4 point, I need to make a relationship to the 3 and the 5, and to do that, I've taken 1/4 of my circumference. I've physically divided it into 3 spaces to get a 1/12 of my circumference, and I set my dividers up for that. And from point 4, somewhere on this arc, is 0.5. Somewhere on this arc is 0.3. Pardon me. Now, let's find 0.5 next. 0.5, here's our plan length of 0.5. Using the 5 triangle that we've created, I'm now going to put down my plan length of 5, or my elevation length of 5. I'm going to triangulate it over the fall, which is ever so slightly bigger, and from A, I get 0.5. Let's document 5. Now, using my 1/12 spacing, from 0.5, somewhere here on this arc is 0.6. We're going to find 0.6 by taking our elevation length, using our 6-line 2-length triangle, plotting over the hypotenuse of that. The fall's getting a little bigger now, and there's our mark. And from A, I get 0.6. From 6 to 7 has this relationship, 1/12 of our stretch out. From A to 7 is this length. Now, since A is on the corner and 7 is on the center, this will be triangulated over the full fall of the fitting, which means all the way to here. And there's the length of my 7 line. I now have my 7. From A to my seam is 4 inches, and I've got that marked here in my plan view. So my next step is to try and find that seam, and somewhere on this arc will be that seam. Our seam from S to 7, or from seam to 7, is in the middle, and in fact is also a true length. So now I'm just going to go from 7, come back, and locate my seam. And I can darken that in. We've got half our fitting built. Next, from B, I need to find 0.3. From B, 0.3 has an elevation length of that. I'm going to use my number 3 triangle once again now. There's my length off of the elevation. My true length is right there, and from B, I get 0.3. From 3 to 2 will be this length right here, somewhere on that arc. We're going to find out by taking our B2 length next. B2 right there, using the 2 triangle. There's my length of B2 right here. And I find my true length by extending it to the mark on the profile. There's the true length of B2. I have 0.2. From 2 to 0.1, I'm going to find 0.1. I'm now going to take and plot from B to 1. Take it to my true length triangle, since I know that 1 is on center and B is not. And I need to triangulate that over the full fall, which is right here. And there's the true length of B1. And there's 0.1. Back to our side. We have a 4-inch dimension from B to our seam. So somewhere on this arc will be our seam, and we're going to find out from taking the plan length or the elevation length of be to 1, which is also the true length of 1 to the seam. It is perpendicular to our plane of vision, rendering it in a true length. So now from 1, I will locate my seam here. And we can draw that in. There we have a nice pitched, squared around and that there is my fitting. Here's how we are going to form it. From B, this will get broke up in a hand brake or in a press brake, depending on the thickness of the material. And that will give us 90 degrees. And then from here, we're going to give these all a break and roll them up 90 degrees. So between this 4 line and this 1 line has to come up 90 degrees. Likewise between the 7 and the 4, 90 degrees. 1 of 2 required. This fitting is now ready for the allowances or whatever proprietary connections you plan on doing on your fitting, but this is the basic layout. From here, it's simply adding allowances. I hope you get something out of this. I am the Draft Doctor. Feel free to subscribe. Hit the like button. Ask me any questions you want in regards to drawing and drafting in the sheet metal industry. I am more than happy to help you out. I hope you all have a wonderful day.